Okay, I will say about location accuracy of the ground station based on RSS, which means received signal signal level in the RISE channel using nonlinear regression function. And in the sequence on after introduction, I say some words about the network structure and the UAV route, and after that about the radio channel and location method and some simulation results. So starting from introduction, you should know that there are a lot of location methods for the radio nodes. They can be classified in connection with, for example, system behavior, system structure, node behavior, etc. The most popular, as you can see here, are time difference of arrival, angle of arrival, and others. But I decided on a received signal strength method because of its simplicity and because of the possibility, first of all, computational possibility and antenna complication on the drone, and I choose multilateration method for location because of possibility of a lot measuring points. So the method is spatial, proactive, without support of GPS, without support of the network. I have one signal source. The node does not cooperate with the drone. I choose a multilateration method based on range-based, RSSI, received signal strength indicator method, which is simple for a simple drone used for location. And what it is for? First of all, let's look on the right on the system structure. It is, for example, constructed with 20 nodes. The system network is clustered. In the center of each cluster, you have a cluster head, and in the range of it, there are regular nodes, and sometimes independent of deployment of the network, and maybe its movement, we can have some unconnected nodes, which is connected with the parameter of connectivity of the system, and the problem is how to find these unconnected nodes and how to connect it to the rest of the network. And the drones, in this example, I'm speaking about only one drone, can be a good solution for a location of such nodes, and next do some things, some organizational, for example, solutions to connect the nodes to the rest of the network. What is more, the nodes are relatively stationary in my example, and the ground nodes do not support the UAV in the location process. Speaking about the radio channel and the drone, of course, the propagation model is dependent of UAV flight altitude, its speed, the environment, urban, suburban, and others. It depends of the frequency, but assuming that the drone is fly above the ground level, for example, more or less 100 meters, we can prove that the RISE channel is good, and for urban environment, the so-called coefficient for the RISE channel can be assumed as 7, and for the rural environment, it can be 14. What does it mean? The decay coefficient in RISE channel is proportional for with the power of the straight signal, direct signal not reflected for any obstacle, and inverse proportional to the sum of power of the rest signals reflected from this located source, reflected from the obstacles in the terrain. On the right and on top, you have an example of fadings of the signal in the raised channel with K coefficients equal to 7, and the top coefficient is equal to 14. As you can see, let's see on the top example, if the coefficient is 7, so the fadings are quite deeper. It is the blue line. Going further, what does it mean multilateration in comparison in trilateration? The oldest method of location is using directional finders, at least 3 of them, with a known location. And if we have such situation, we can estimate the distance with the source of the signal to the directional finder. And if you have at least 3 finders, we can estimate the position of the signal source. And we can write 3 equations for this. But on the other hand, if I have a lot of measuring points, I can write such equation when I means the distance estimated with I directional finder. Here in my example, the drone. Before the location of the signal using multilateration method, it is good to filtrate the signal to smooth the fadings related with the raised channel. And I use a lot of to compare a lot of filtering methods, starting with Kalman filtering and a couple of moving average methods, and they are compared here on this picture. What is what you have to remember? The moving average filtering was using different windows which are suited to the best results. It is not automatic optimal solution. I will find it in next procedure. Using nonlinear regression function, I provide the model function in the like this here, but it is what is important. It is suited to the main equation connected with the multilateration procedure. In this equation, x is connected with coordinates of UAV at each measuring point, and b are coordinates of the node being located. What is more, I average the results by 30 raised channel conditions and by 4 turning radius on UAV using K parameter from 7 to 14. As a result, as you can see here on the left picture, in comparison to the situation with no filtering and after filtering, I lower the error can be lowered 2 times, and the standard deviation for estimation position is from 20 to about 25 meters. In conclusion, it can be seen that accuracy is not significantly dependent on the noise variance, And if you have only additive white Gaussian noise channel, the accuracy is about 2 meters. But in the race channel, the accuracy is about 10% of the absolute distance from the signal source. And after filtration, we can have, using, of course, this nonlinear regression function, the accuracy about 5% of the distance from the signal source. The next step of research will be to verify the results in the relay radio channel. It is a situation when the drone is moving not high on the ground, above the ground level, for example, among the high buildings. And I will try the different channel with find to optimal parameterization of channel filtration systems, as well as I will search for more effective position estimation algorithm based on RSSI, for example, maybe a so-called ROC RSSI or min-max and others methods to have the better estimation position results. What it is for? It is for having connected networks, which is can be applied in the typical radio systems, as well as sensor networks, which nodes are deployed in different ways. For example, using helicopters and other ways. Thank you for your attention.
Okay, Janusz, please ask a question.
I am not sure if I well understand the presentation, because in presentation you are talked about the drones, but in the formulas there are no third coordinates. Are you make the estimation in surface or in 3D dimension area?
On surface.
Okay, okay.
I use simply I use the right propagation model, and K coefficients is suited to the results connected results in other example when K is from 7 to 14. It is suited to the drone above the ground.
Okay, okay.
I don't need the three-dimensional coordinations.
Yes, it is possible to use your methods to estimate the localization, the elements of the sword and the group of drones which are going from one place to another.
Do you ask me if I can use a set of drones or to locate a set of nodes?
Yes, it's a group of drones which start with one position to another one, and we are going together in a small distance between.
I'm not sure if I good understand you. Your aim is to locate the drones or ground stations.
No. I am interested in location of the drones. So I think it is okay.
So first of all, I'm locating here the point as a source of the radio signal. So the source can be of course everything. It is not important. It is a drone or the node, but of course the important is the speed of the movement.
Okay. Understand. Thank you very much.
Thank you, Janusz. I have one more question to you. Do you check how your solution is resistant to radio interference from, for example, foreign sources?
No, I not, let's say, introduce any interferences. It's the other problem.
Thank you very much, Jarosław, for the presentation.